Welcome back at C Squared. In this lesson we'll talk about isosceles triangle at the beginning, and then we're gonna talk about equilateral triangle. And you see here what an isosceles triangle is an isosceles of at least two sides congruent. And you notice here we can see these two sides are congruent. These two angles are going to be also congruent. We call them the base angles. These two sides are called the legs of the isosceles triangle. BC is called the base, and this is what we call the vertex angle. Very similar in the other triangle, which is an obtuse triangle, but however we can have an obtuse triangle that is an isosceles triangle. These are the legs. This is the base. This is the vertex angles, and these are the angle base that are also congruent. And let's see a first example here where we have to find the value of x and the length of each side of this triangle ABC. What we should notice here is the fact that these two sides are congruent, which I'm going to write it right here, AC congruent with BC, which means AC, the measure of side AC is the same the measure of side BC, which means 5x minus 3 equals 3x plus 7. So here I'm going to subtract 3x to solve for x. I have to do the same thing on the other side. And we have 2x minus 3 equal 7. Add 3 here. And we end up with 2x equal 10. Divide by 2. And that will be x equals 5. So we did the first part, find the value of x. Now we need to find the side of the length of each side. So let's start with AC, which is 5x minus 3. So that means 5 times 5 minus 3. That will be 25 minus 3. That will be 22 feet. You can do the same thing for BC, or you can simply say BC is 22 because these two sides are congruent. We have an isosceles triangle. And let's find AB now. AB is 6x minus 3. So that will be 6 times 5 minus 3. And that will be 30 minus 3, and that will be 27. That is how much AB is, and we finish this example. Let's take a look to the next thing, which we have another isosceles triangle. How do we know this? We notice this sign, and we have to find the value of x and y. We notice x belongs to these two expressions which represent these two angles which are congruent. Those are the angle bases, right? So because AC congruent to BC, we can say also angle A congruent to angle B, which means the measure of angle A is equal to the measure of angle B. And now we can write the equation, which is 2x plus 12 equals 4x minus 12. I'll subtract 2x here to get rid of this positive 2x. Don't forget to do the same thing on the other side. So then we have 12 equals to x minus 12 at 12, and we have 24 equals to x, divide by 2, and we end up with an x of 12, which is the first part. Find the value of x. we need to find the value of y. And now for finding the value of y, we really need to find the measure of one of these angles. Let's say angle A. That will be 2x, so 2 times 12 plus 12. So that means 2 times 12, 24, plus 12, that will be 36 degrees. That's the measure of angle A. The measure of angle B will be the same, because these two angles, if you remember, are the same. The angle basic, 36 degrees. So now we can find the measure of angle C by just saying measure of angle A plus measure of angle B plus the measure of angle C equals 180. The sum of the measure of the interior angles of a triangle is 180. So we have 36 plus 36 plus the measure of angle C, which is 6y, equals 180. So now we have an equation in y. We're going to combine these two numbers, 36 plus 36, that is 72, plus 6y equals 180. I'm going to subtract 72 on both sides for cancelling out the 72. So we have 6y equals 180 minus 72 is 108. And the last step will be to divide by 6. Divide by 6 on both sides, like I said, and that will be 18. Y equals 18. Let's see some theorem involving isosceles triangle. And this, the first one, the isosceles triangle theorem, it says if two sides of a triangle are congruent, then the angle opposite those sides are congruent. I already used this theorem in a previous problem. That's what it says. You notice RS congruent to RT, then these two angles are congruent. Okay, and I think I just used it a couple minutes ago. Now, this theorem has a converse which says if two angles of a triangle are congruent, then the opposite sides, then the side opposite those angles are congruent. So, in this case, you notice these two angles are congruent, S and T. That means these two sides are congruent. So this is the converse of the previous theorem, which it's very useful to prove more theorems, more problems. Now let's move to the second part of the lesson, which is about equilateral triangle. And this is an equilateral triangle that is a triangle that has all sides congruent. And you notice that in this picture, all these three sides are congruent. An equilateral triangle also it's called an equiangular triangle. Why? Because these angles are going to be congruent because all sides are congruent. You see here on this second picture, and I also said just because of that reason each angle should be 60. Why? 60 plus 60 plus 60, that will be what? Nothing else than 180 degrees. The sum of the measure of the interior angles of a triangle. So let's see now the next example. In this problem we have an equiangular triangle, it's called, but we know an equiangular triangle means also an equilateral triangle. And now we have to find how long each side of this triangle. All these sides are congruent. Okay, so we can write three different equations like what? 8x minus 13 equals 4x plus 1. But also you can write 8x minus 13 equals 6x minus 6. And the third one will be 6x minus 6 equal 4x plus 1. It really doesn't matter which one you solve. Let's say you do the first one. I'm going to subtract 4x here to get rid of this 4x. And I'm going to have here 4x minus 13 equals 1. I'm going to add 13. And I get 4x equal 14 and divide by 4. X equals 14 over 4, or you can simplify. That will be 7 over 2 or 3.5. It's up to you how you like it. Probably the last two are the best. If you solve this equation, you should get the same thing. X equals 7 over 2 or 3.5. The same, if you solve this equation, you should get the same value. How long each side? Then we have to plug it in. You plug in one of these expression. Let's say you plug in 8x minus 13. 8 times 7 over 2. I prefer this one, this form, minus 13. That will be how long AB is. So now we can simplify here. 2 goes in 8 4 times, so we're gonna have 4 times 7, that was 28 minus 13, that will be 15. AB it's 15. AC will be also 15. And BC will be also 15. And that's it for this example, this problem. Sometimes you have to deal with triangles in the coordinate grid, rectangular grid, and let's see how we do it. Example, use this diagram below to find how long AC is, BC is, AB, measure of angle A and angle B. Round to the nearest 10 if necessary. So I'm going to start with the easy part to find how long AB is. That's simply counting 1, 2, 3, 4, 5, 6, 7, 8. AB is nothing else than 8 units. Now let's find AC now. AC, we can draw this right triangle. Again, we're going to count 1, 2, 3, 4. This is 4. 1, 2, 3, 4. This is 4. We have a right triangle for which the legs, the A and B's, are 4. So I can use A squared plus B squared equals C squared. So that will be 4 squared plus 4 squared equal C squared. 4 squared is 16, so 16 plus 16 again, right? Equals C squared, and C squared equals 32. C squared is nothing else than, in fact, C is nothing else than this side, AC. So AC will be square root of 32, which we can simplify. That will be 16 times 2, and that will be 4 square root of 2. And I'll leave it like that. If you really need to do a approximation, grab a calculator and do it. And now let's move to BC. BC, if you notice, we can do this triangle, but what do we notice here? 1, 2, 3, 4. 1, 2, 3, 4. So BC, if you do the math, is gonna be the same with AC. No reason to do it. It's gonna be 4 square root of 2. Okay, so that tells us that triangle ABC is an isosceles triangle. Okay, which tells us, because AC BC are congruent, right? And now we know then the measure of the angle A and angle B are congruent because those are going to be the base angle. And this angle C is 90 degrees. So what I'm going to do now, I'm going to write this theorem, right? The measure of angle A plus the measure of angle B plus the measure of angle C. If we add these three angles, the sum of the measure of the interior angles of a triangle is 180 degrees, right? So I can replace this measure of angle A and measure of angle B. They are the same, right? With an X, I think it's easier to handle the last part of this problem. Or you can keep it like that if it doesn't bother you. Now we have here X plus, and angle C, let me write that here, is 90 degrees. 90 degrees, why? Because you see that box there. Plus 90 equals 180. And we have 2x here, plus 90 equals 180. To find x, I'm going to subtract 90. And we have 2x equals 90 and divide by 2. We have x equals 45. Don't forget what this x is. This x represents the measure of angle A. (45 degrees). The measure of angle B is 45 degrees also. So let's take a look. We did find AC, we found BC, we found AB, and the two other angles. We know everything about this triangle now. In my next problem, we have a diagram and we need to find the measure of angle D, which is this angle here, which is the base angle, right? Because this triangle here, we notice, is an isosceles triangle. But also, what kind of triangle is this one where all these three sides are congruent? That will be an equilateral triangle. I'm going to write it here. Triangle ABC is an equilateral triangle, which means is also an equiangular, which means a measure of angle A is the same with the measure of angle, I'm not going to call it B because we have multiple angles of the same vertex, ABC, and this is equal of the measure of angle BCA. All these three angles are 60 degrees. These three angles are all congruent. But the one I really care is this one, 60 degrees, because that will allow me to find another angle. It's going to allow me to find this angle, because this angle CBD plus the measure that is 60 degrees, which was ABC, measure of angle ABC. They form a line, so they are supplementary 180. So I can find the measure of angle CBD now by simply subtracting 60 degrees from 180, like I did it here. So what do we have here? We have the measure of angle CBD equals 120 degrees. This angle here is 120 degrees. Now, we have to do one more thing to find the measure of angle D, this guy. I'm going to call this one X, and this angle is also X. If we add this triangle in triangle BCD, what do we get? We get 180 degrees. And this is an isosceles, if you remember I said that. Okay, we can see that in the picture. So I'm gonna write here a statement very similar of what I did before. So we're gonna have the measure of angle D, the one we need to find out, plus the measure of angle, I'm not gonna call it just C, we need to use three letter BCD, it's one way, plus the measure of angle CBD, the one we just found out. If we add these three angles, that will be 180 degree. Okay, so now this angle BD, I will call it X like I said. BCD, it's also the same because it's an isosceles triangle, and the measure of angle CBD is 120 equals 180. We're gonna solve this equation. 2x plus 120 equals 180. So subtracting 120 will be my next step. And we have 2x equals 60, and the final step here is to divide by 2, and we get an x equals of 30. But again, remember what x is. We call this angle dx, so the measure of angle D is 30 degrees. Okay, so let's move to the next example. And this example, you really need to look to your picture. And for example, on the first picture, what do you notice? We notice these two sides are congruent. That means it's an isosceles triangle, and this angle, the vertex angle, it's 60 degrees. How much are going to be these angles? If you notice, I marked them the same, okay, and they are congruent because triangle ABC is an isosceles triangle, right? So the base angles are going to be the same. So let me write that here, triangle ABC isosceles. So from 180 degrees, I'm going to subtract 60 degrees, this angle. That will be 120 degree, and I'm going to divide that 120 degrees by 2, and I get a 60. That tells me each angle here is 60 degrees. Oops, 60 and 60. Oh, so in fact what we have here is an equiangular triangle. Yeah, it's an equilateral triangle. Okay, and now we kind of justify the reason for writing this equation, 2x plus 10 equals 3x minus 6. If you do not know that the triangle is equilateral, you cannot write this, but now we're looking 60, 60, 60, the angles we know. AB is congruent to AC and BC. So I'm going to subtract 2x here to cancel these 2x, and then we have 10 equals 3x minus 6. I'm going to add 6. And I will have 3x equals 16, and the last step, divide by 3. X equals 16 over 3. I'm going to leave it like this in this case. Let's take a look to part B, which is very similar. We notice now these three sides are congruent. So what do we know about this triangle? It's an equilateral triangle, triangle DEF is an equilateral triangle. But equilateral triangles are also equiangular. So we kind of justify now my next step where I said this angle is 60, this angle is 60, and moreover this angle it's 60. So that allows us to write right away this equation, 5x equals 60 divided by 5. And we have x equals 12. And that's it for this problem. Again, if you need to justify your answer, you need to find statement like this, and you see I follow logic steps. It's kind of a proof. A very similar problem. Now we need to find on part A the measure of angle C and the length of AB. And you notice, again, these two sides are congruent, so it's an isosceles triangle. That tells us this angle and this angle are congruent, so this will be 60 also, which means this will be 60. No way, right? 60 plus 60, 120, and 180 minus 60 is 60. So the measure of angle C is 60 degrees, which tells us all these angles are equal, so the triangle is equiangular and is also an equilateral triangle. So AB is congruent to the other two. AB is congruent to AC and AB because it's an equiangular, which is an equilateral triangle. So that tells us right away AB should be 5 feet. On part B, very similar, we notice these two sides are congruent. Why? Because they both are 7 inches. So now we have an isosceles triangle. This is 60 degrees, so I'm gonna do 180 minus 60 degrees, and that will be 120. That means the sum of these two angles here, it's 120, and you see I marked them the same. So I'm going to do 120 divide by 2, and that will be nothing but 60. Each angle in this triangle is 60 degrees. Okay, so in fact this isosceles triangle is an equiangular triangle, which means is an equilateral triangle. This also is congruent to the other two. So the measure of angle D is 60 degrees. We prove that. And DE, the length of DE will be 7 inches. So in this example, these two isosceles triangles are in fact equilateral triangles, but you have to justify why. And my last problem in this lesson today is going to be a proof. Sometimes you're going to have to write a proof, and you can choose a 2-column proof or a flowchart or a paragraph proof. I would like the first two more than the last one. Okay, so if you remember, on both ways we have statement and reason. Let's try a flowchart, and I'm going to start with angle R. I hope I have enough space here. Congruent with angle T, and if you remember, on a flowchart you need to do a box like this and write the reason, which is given. From this statement here, I'm gonna have another one which says what? RM, so by the way, these two angles are congruent, right? My next statement, the logic statement that comes from this one, is that RM is congruent with MT. And why? If you remember, just 5 minutes, 10 minutes ago, we have a theorem, the converse of an isosceles triangle. So that will be my reason here, converse of isosceles triangle theorem, something like this, right? So because these two base angles are congruent, we know triangle MRT is an isosceles triangle, so MR has to be congruent to MT. Okay, these two angles are also congruent, and also you notice we have another statement here that says RN congruent of PT, and you see I mark them like this. Okay, and that will be my next thing here to write. So I'm gonna say Rn congruent of PT, and the reason is very simple. It is given. Now I want you to take a look to my picture on the left. You notice here we have these two sides congruent, these two sides congruent, and the angle included. That tells us something about those two triangles. The triangle MRN and the triangle MTP, they are congruent. So look at here what I'm doing. Okay, I'm gonna write these two triangles, and you need to be careful here. They have to be corresponding letters. So I said MRN. You can start any other way. Congruent of triangle MTP. And what's the reason? Like I said, there are two corresponding congruent sides and the angle included by side angle side. Okay, let me do a box here, and you see that's the statement and the reason. Again, you may want to look here. This is the angle and these are the two sides, and the angle is included, so you can do something like this. Good. And now how can I prove MN congruent? These two guys are congruent. We have one more step, one more arrow, which is in fact the final thing, right? I'm going to say here MN congruent to MP. And what's the reason for these two sides being congruent? Because the corresponding parts of congruent triangles are congruent. CPCTC is how it's spelled. Corresponding part of congruent triangles are congruent. So now we end up the flowchart. Of course, you can do a 2-column proof if you like that. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.